when we are talking about surface area and volume, we are thinking of a three-dimensional figure. So, a rectangle, we measure the area by saying length times width. That's it. It's a flat piece of paper. There is not that third dimension that comes when you make that piece of paper into a box. So when you're measuring the volume of a rectangular prism, you've got to have three dimensions. So all of these shapes are three-dimensional. A rectangular prism, a right prism, a cylinder, pyramid, cone, sphere, they are all three dimensions. And if you look over here at their formulas, you'll see three dimensions: length times width times height. Now this one looks like it only has two, but I'm going to show you why it has three. Okay, that's one of the things that we need to look at. But look at these pictures just so you know what we're talking about when we say anything that calls itself a prism. Three dimensions. So you can see that this shape right here is a rectangle, but when we add this third dimension here and give it some depth, then we're making it a prism. So a rectangular prism is a box that one side at least is a rectangle. A right prism, this is actually in its full name is a right triangular prism, meaning that the right angle is at the base and the height. So right here is the right angle. Not that this triangle is a right triangle, although it could be. When we say a right prism, that means that it's going to have a right angle, making it stand up straight rather than being slanted. And that would be an oblique prism, but we hardly ever talk about those. And then this is a pyramid. Notice that the base of the pyramid is a square, and then the sides are triangles, and they come up to a point. I always used to get these, in fact, I still do sometimes get these confused. Which one is the right or the triangular prism and which one is a pyramid? So if you compare the bases, the pyramid has a square base and the prism has a triangle base, unless it's on its side, and then this is the base. It kind of depends the way you're looking at it, but the ends of it are triangles, not a square. Okay, does that make sense? See how the pyramid comes up to a point? Side feet at a vertex. That does not happen in a prism. Okay, so these are the technical terms that you need to get in your head. And they have actual definitions, but to me, it's easier to see if you've got a picture and you can remember the picture rather than, the actual definition, which gets technical and confusing. So there's a really important point that can also be confusing, and that's the difference between the capital B in a formula and lowercase b in a formula. So the capital B is the area of the base, and the lowercase b is just one side of a shape. So I'm going to go back and look at these here. Maybe
That's something I never knew that.
Excuse me? Okay.
Okay.
You're just looking at a triangle. This line is the base. See how it says lowercase b here? It's talking, if you're just looking at this two-dimensional triangle, this is the base. When we figure area of the triangle, that is the base of this right prism, then that becomes uppercase B. And I'm going to go back to show you what I'm talking about. Actually, I'm going to go back even one more. So the area of a triangle is 1/2 base times height. And that base is lowercase b. So I'm just talking about a line on a two-dimensional triangle. When I, hello, come on. When I am talking about the volume of a prism, here it is, it's uppercase B, and that is area. So that's 2 dimensions because that's lowercase b times the height of the triangle times the height of the perimeter of the prism.
Okay, so I have a question.
Yep.
So is the uppercase B only for the prisms, or are they only for the 3-dimensional shapes?
Yes.
Okay.
Because it stands for base of the prism. So it's this whole thing. So the area of the base. And you can look at this. Here's the interesting thing. It doesn't really matter which side you call the base, whether you call the triangle the base. So like in this one, you would think of this triangle as being the base of this prism. In this prism, which is the exact same shape, it's just turned on its side, you would think of this rectangle as being the base. And it really doesn't matter which way you do it because you get you're going to use all the same numbers and multiply them. So whichever way you do it, it's going to work out. Okay. We'll take a look at a couple and you can see why that would be. But it doesn't matter which one in these two prisms, which one you call the base, whether it's this triangle or this rectangle, you're going to end up multiplying the same things together. And it will be okay. You will get there. So let's see. Yeah, so we were talking about the difference between capital B and lowercase b when we're using formulas. So capital B stands for the area of the base. You must compute the area of the base, whether it's the rectangle, a trapezoid, a triangle, whatever shape that base is, and substitute in for that. If it's a lowercase b, it's just one side of the shape. And specifically, it's the side from which the height is measured. So we'll take a look at what that means. But that's really critical, knowing that it's uppercase B or lowercase b, and what does that stand for? Other three-dimensional shapes. A cylinder is think of a can, a cone, we think of an ice cream cone, and a sphere is a ball. And to measure those, this is giving you the specific things you need to measure the cylinder. First, what you're going to do is find the area of the base, which is a circle. So we use the formula for the area of a circle, which is pi r squared, r being the radius. So you need to know that dimension, and then you multiply that area by the height. How tall is it? And that will give you the volume of the cylinder. The cone I have to look at this one. I never remember what the formula. I think it's 1/3. Where is it? Yeah, 1/3 pi r squared height. And don't forget, like I said, I never remember these. You will have this whole page as part of the GED. So you don't have to memorize them if that's not something you want to give brain space to. You will have it here.
Okay,
Okay.
and that volume. So is that 1/3 times pi times r squared times height?
Mm-hmm. So if we were looking at this cone, come on, we were looking at this cone. If this, let's just say this radius was 9 and this height was 15. Oh, that's,
Mm-hmm.
we can't do that in our heads. Wait a minute. Let me step back from that. If this height is 3, I mean, this radius is 3 and this height is 5. So radius squared, do that
Mm-hmm.
first. You're going to do the exponent
Mm-hmm.
and you will get 3 squared. Let me write that down.
9, would it be 9 times 15?
What did I say the height was? 5, right?
5?
So
Yeah,
1,
5.
so volume
Oh,
equals pi r squared times the height. So the volume equals 1/3 pi 3 squared times 5. Volume equals 1/3 pi 9 times 5. What's 9 times 5?
45.
1/3 pi times 45. And so 1/3 of 45 is 15. So 15 times pi. Oh, good morning, Monica. I didn't see that you joined us.
1, whoa, 15 times pi,
Good morning.
Uh-huh.
47.25.
That seems right. Okay.
Well, it's
I
okay.
wrote down the formula. This is my good mathematician tip for you is to write down the formula, substitute in your values, and then solve one step at a time. And then you would get the volume equals 15 pi, and we know that pi is 3.14. If we substitute that in,
3.14.
yeah, that is the acceptable shortcut to use because pi is an irrational number, so it goes on forever. It's
Right.
3.14159. So most of the time, we use 3.14. But you also have a pi key on your calculator, usually that you can use. And if you find that using the pi key doesn't give you an answer, you might go back, that's in your multiple choice list, you might go back and substitute in 3.14 and see if that gives you the answer. Okay. So let's go back to look at our screen. Okay, so we were talking about 3-dimensional shapes and just to remember what those shapes are. Okay. So we had talked about these area and volume questions. And surface area being if you're thinking of surface area, it's how much paper would I need to cover a box. That's what surface area is. There's the formula.
Like if I wanted to paint my room, I would have to figure out how much gallons of paint I need. Does that kind of make sense?
Yes, it does. And so
Okay.
let's just think about that. What shape is the room?
It's a rectangle.
Okay, so what dimensions would you need?
Um um a right prism.
Well, if you're thinking of it that way, you would then be saying, I'm going to paint the ceiling and the floor, right?
Yeah.
And when you actually, and that would be your surface area, right?
Right.
So you sure could do it like that. That would give you the surface area, ceiling, floor, all four walls. And then you would find on you would take that total number to the store and you would say, this is the total area that I need to cover. And they would say, oh, well, this paint covers so many square feet per
Okay.
gallon. And you would figure out the gallons from there. But the next thing that
Okay.
you would need to know is how many square feet does a gallon of paint cover?
Right. So first we would have to measure the the room, but the room would be a three-dimensional shape, right?
You can do it like that. Or usually when I do it, because I'm painting the walls and just the walls one color and the ceiling a different color, I figure out the area of each side of the room and then add that together. And then
Okay.
So you would take the base times the height of the room
right,
to get the area.
and do that. Usually a room is a rectangle. So I figure out
Mhm.
the area of two sides, add that, and the area of one side, multiply that by two, because usually the room has,
So you would times those together.
yeah.
Okay. Kind of get it. Thanks.
Okay. So here's the interesting thing. I tried to figure out, why do we ever need to find the area of a triangle? And I know in construction, yes, there are times that you need that. I could not think of a single real life example where we wanted to find the area of a triangle. But triangles are so interesting in math. And so, it's an easy formula to figure out. And I'm going to show you something about that. But take a look at this first. What formula do I use to figure out how much wire I need to make the triangles in these earrings? What formula is that? Think about all the formulas we've talked about. We've talked about area,
The
perimeter,
area of a circle.
volume. Think about what the area means.
The area of a circle. The circumference of a circle.
Well, the circumference, definitely, because that is just the length going around the outside. It's not inside the circle. So we're going to figure out the circumference of the circle. What are we going to figure out about the triangles?
The diameters or the um
You would take half half the base times the height to figure out the area of the triangle.
That would be if I was finding the area, but do I need to do that to make these triangles?
You need to find these.
Because I'm not looking for how much I need to go inside the triangle. I'm looking for what I need just to go around the outside. What do we call that measurement?
The outside.
Mm-hmm.
Is it the diameter?
Diameter is the measurement across the center of the circle, edge to edge,
I don't know.
going through the center. So that is, diameter is strictly a
Is it
measurement.
the surface area?
Make me feel a little special.
It is not, because
No.
again, that's telling me how much area, the space inside.
The volume. The volume. Is it the volume?
Nope, volume is
No.
3.
Okay.
I will tell you, it is the perimeter.
The perimeter.
Yeah,
Okay.
yeah, we're just going around the outside of that triangle. So all
Right. The
we do is
okay.
add up the length of the triangles, the sides. So it's side plus side plus side. These look like they're equilateral triangles, and I would think if they're in a circle, that would be the case, that they would be positioned so that they're equilateral. So it's probably the same number over and over again. So whether it's, I don't, maybe a half inch or a quarter inch, probably a half inch. Half plus half plus half. And then if I want to know how much I need to make both earrings, what do I need to do once I find the perimeter?
You have to okay, say that again. You said
How much do I need to, if I want to make both earrings, what would I need to do with the perimeter?
you would
Once
have
I
to measure. Once you what?
once I find the perimeter for one earring, what do I need to do if I want to know how much to make both earrings?
You have to find the perimeter of the other, or double it, or square.
Yes. No, you are correct. Double it.
Okay.
If
Okay.
I square it, I multiply it by itself. If I double it, I multiply it by 2. So I
Right.
have
Okay.
2 earrings, so I want to multiply it by 2.
Okay.
And
You just want to multiply it by 2 because it's 2 ears.
right, correct. And then you already said, how much do I need to figure out how much wire I need to make the circle? You told me the circumference, which is pi times the diameter. And remember, the diameter has to go straight across from edge to edge and go right through the center of the circle.
Right. And the diameter is the radius squared because the radius is half of the diameter.
It is not radius squared. That would
Okay.
be radius times radius. It is
Okay.
the other one, doubled. The radius times 2.
Radius, right. Okay, radius. Okay, I always get those two messed up. That's why I have to do it both ways to know which is the answer.
I yeah, things like that confuse me too, and I have to
Yeah.
which answer makes the most sense.
Right.
So think of
Okay.
it that square is you're finding the area of a square. That's why it's called that, because you're squaring it because you're multiplying the same number times itself. So let me see if I can just give you, maybe this will help. So if we have a square, what we know about a square is that all the sides are equal. So if this square is 4 inches, all the sides are equal. And if I want to find the area, I'm going to say 4 times 4. And 4 times 4 is the same as 4 squared.
Right,
That's
because it's
where the term comes from, because it's
okay.
what you need to do to make a square is multiply the sides times, itself. So that is totally different than saying the length of these two sides is 2 times 4. 2, 2, that's a really bad 2. 2 times 4, which is 8. 4 squared is
Okay. 4 squared is 16.
perfect. That's totally different.
Right.
So yes, keep reminding yourself. 4 times 4, 4 squared is a totally different thing than 2 times 4.
Okay.
Okay. All right. Let's get rid of that. Okay. Yep. All right. And go on to,
Now this perimeter, I had one
yeah,
question.
go ahead.
When you say S plus S plus S, what is S? Is that the sides of the triangles?
Mm-hmm.
Okay. Okay, so that way we know, how big or small we need to make the triangle inside of the circle.
Mm-hmm. So if this side was 1 inch, it would
Mhm.
be 1 plus 1 plus 1. So we would start here and go 1 inch plus 1 inch plus 1 inch. So that would be
Okay.
3 inches to make this triangle, and another 3 inches to make this triangle. And then we'd have to figure out what is the diameter, which we don't know, because we could figure it out. It would be, it is possible to figure out if we know this, but that's a little bit beyond what we're doing right now. Right now we don't know the diameter, because this length is neither the diameter or the radius. So we're not exactly sure, but we would have to measure to find the diameter. It's longer than an inch, so let's just say it's 1.5 inches. So we'd have to say pi times 1.5, and that would be 47 something, 4.7. Okay.
Okay.
So this is what I wanted to show you to help you remember what is the area of a triangle. So if of this rectangle right here, this outside rectangle, if I wanted to know the area of this rectangle, what 2 dimensions would I use?
When you say dimensions, could you explain that?
Yep, a dimension means length, width, height, radius, diameter.
Okay, and you want to know the area of that?
Of the entire rectangle.
So we will have to find the formula, right?
right?
And the formula of a rectangle or a rectangular prism?
Which one is this?
I think that's a rectangular prism because it's three-dimensional.
It does have some depth to it because it's 2 inches, but for right now, I am not concerned about that. I just want to know the area of this rectangle. And if I'm talking area, I'm only talking 2 dimensions.
Length, length and width?
Length times width, yes. So that's the area of this rectangle. But look at
Okay.
the diagonal line right here. See how it makes this rectangle into 2 triangles, one here and one
Yeah,
here?
yeah.
Okay. And it divides this rectangle exactly in half. So this diagonal line
Is what the diameter?
angle in half. And that's why the formula for the triangle is 1/2
Uh-huh.
base, which would
Times
be
height.
width, times the height, which would be this length here. So we call those measurements different things depending on whether it's a rectangle or a triangle or a square, but really it's using the same numbers. So we're using different words depending on the shape, but the numbers remain the same. So that's why every triangle is
Okay.
half of
Right.
some rectangle. And that's why we get that 1/2, the base, the lowercase b. So we would use this dimension times the height of the triangle. So we would use this dimension, and that's
Mhm.
1/2 of the length times the width of this rectangle.
So is the length of it, is it 45 or 48?
Well, that's where the that depth comes in that you're talking about. So it's
Okay.
saying this piece from here
Right.
is 45, and
Mhm.
add this little bit of
Yeah.
height here and here. That's where you get
Okay.
the 48 from. So it depends on which one you want to measure. Let's say we want to
Okay.
measure the
The
so
35. The
the outside. Let's say we wanted to measure the area just for the outs from top to bottom, outside here to here, then we would use the 48. But if we wanted to say put some glass in here, like this is going to be a window, we would measure inside 45, and we would have to account for this. So we would be, it looks like they're saying the inside of this, so 33. So depending on what you want to use. Yeah. Okay.
Oh,
Now, the other critical thing
I
about
always struggle with this kind.
triangle is that the height is the length of a perpendicular line drawn from one side of the triangle to the angle opposite. So in a right triangle like this one right here, it's easy to see that the height is the length of one side. You see how we have these here? And then
Mhm.
because it is a right triangle, this is a right angle. So we can use this side length as the height. But in other triangles, any kind other than a right triangle, we have to find that height. It is
Yeah,
not one of
because it
these.
doesn't have a 90-degree angle. You have to
Okay,
make a 90-degree angle.
correct. So you can't use a slanted side as the height. You have to use, whoops, we have to use, go back. Oh, me. My. Go back. There we go. We have to use the perpendicular line segment. Okay. So let's look at an example. Again, I told you I couldn't think of a single real life reason why we want to find the area of a triangle. So, because we're not talking about construction. So what is the area of this triangle? How would you figure it out?
You would do half times the base times height. So you would do base times height, and then you would divide it by 2, be half.
Perfect. So what is the base of this triangle?
The base of this triangle, the base of this triangle is 21.
Perfect. And the height?
8.
8.
So it would be 21 times 8 divided by 2.
Yes.
2 gives me 84. The area is 84. Is it 84 feet? 84 square feet?
84 feet squared. So the area is exactly what you said. There's the formula, and we substitute in 1/2 times 21 times 8, and we get 84 feet squared. Perfect.
Okay.
And then what is the perimeter?
The perimeter is 31, 41, 48.
It is.
No. Oh, it is 48 because instead of adding the 8 is one of the sides, I did the 10.
Okay.
And
Oh
no, the answer's right there.
It is. But I made a mistake. Do you see my mistake?
No.
So the perimeter is side plus side plus side. So there it is. And I heard you say 51. So you did that quick without even hesitating.
Yeah.
10 plus 21 is 31. Plus 17 is 48.
40.
And
Yeah.
what mistake did I make in my answer?
Huh?
What mistake did I make when I put my answer in?
I have no
put
idea.
48 feet squared. Is perimeter a squared measurement?
No.
No, it is not.
It's just
It's
the
linear.
perimeter is just the sides around, right?
That's right. It's just linear feet starting from here to here. We only added, we didn't multiply anything. So the answer should just be 48 feet. Good. Okay. So yes, we all make mistakes sometimes.
Okay.
So there it is, the side plus side plus side, 21 plus 10 plus 17, 48 feet. Okay, so this is, here is a real life example. My husband and I, during the quarantine, were taking lots of walks along the Cleveland Metro Parks, and we were on the east side, the Canalway Center, and we came across this huge gasoline tank. And I said, oh my gosh, I'm talking about volume. This is perfect. So look what it says on the side. I don't know if you can see that very well, but it says the height of this tank is 48 feet and the diameter is 120 feet. Now, it tells you also what the capacity is.
What kind of shape is that?
What shape is it?
Yeah.
It's a cylinder, ain't it?
It is a cylinder.
Okay.
So what formula would you use to figure it out? So when we get the volume, are we going to get the 4 million gallons? Is that what volume gives us?
No.
No. So first of all, what is the volume is going, because this is in feet, don't forget the
The
volume is
volume
going
of the
to
cylinder
be in
is pi
cubic.
times radius squared times height. Um. Okay.
Radius squared times height. So what is our radius? Did they give us that
Um.
information?
Our radius is 60.
60. Beautiful. So the volume is going to be pi times 60 squared times
48.
48. Beautiful. Now what do we do?
60 times 48 is 2,880 times 3.14. Wait, no.
Did you square your radius?
Radius squared. Oh, okay. That's what I did wrong. Okay.
So square your radius.
Okay. Times 48. 48 times 3.14. I'm getting 18,000.
Okay. Let's see here. We get 60 squared, which is what?
Radius squared.
Yeah, your 60 squared. What answer did you get for that?
Um, 3,600. 60.
Beautiful. So now we
60.
have pi times 3,600 times 48. What do you think we should do next?
Um, do we divide it?
So this is what where did it go? This is what I have so far. We got the volume, IR
Okay.
squared times the height, and then we said pi times 60 squared times 48. So we just substituted in. We got pi times 3,600 times 48. What's the next step we should take to solve this?
We have to times all three. We have to times um 3,600. 3,600 times 48 equals 1,172,800 times pi
Mm-hmm.
0.14 gives me 542,592. I have no idea what you do at next.
Okay, hang on. So did you say pi times you got 172,800 when you
One,
multiply?
yes, yes,
Okay, and then we're going to multiply that by 3.14,
yes.
and we get
542,000.
42,592.
Mm-hmm.
What?
That's our
What's our
value?
It's the volume, but what did we multiply together? What units did we multiply?
Um, was it gallons?
No.
No, I can't move my screen over.
Yep. Hang on.
Okay.
What does this symbol mean?
Inch.
Feet.
Feet.
Is that
Yeah.
feet? Oh, that's feet.
It's feet.
Yep. If it's a double quote, that's inches. So this is feet. So our volume is, we've multiplied the radius times the radius times the height. So our volume is, which we write that. Instead of feet squared, we put, oops, where'd it go? Feet cubed,
Feet cubed.
3.
Why is it feet cubed?
Okay.
What makes it feet cubed?
Because we, that's an awesome question. Because we multiplied 3 dimensions.
Three
We
different.
multiplied,
What you
remember
doing?
the formula for the circle, the area of the circle at the top or the base. We found the area of the base by saying pi r squared. That r squared is actually 2 dimensions, radius times radius. That gives us the area of the circle, and then we multiplied that by a third dimension, the height. So the area of the base of this tank, which is a circle, is pi r squared, and find the area of a two-dimensional figure. We're multiplying 2 dimensions. In this case, it's a little bit sneaky because it's radius times radius, but that is 2 dimensions. And then the third dimension is the height. So volume is always cubic something. It's
Right. Okay.
cubic miles, cubic feet, cubic meters, cubic centimeters, but it's always whatever that dimension is to the third power.
Okay.
Okay, and then I have a note here somewhere. Let me see if I can find it. Nope, that's not what I wanted. Goodness gracious. Okay, I'm gonna have to get rid of my note here tells me where did that capacity, that 4 million gallons, how did they figure that out? I was just curious because all I knew was, wait a minute, when I figure out the volume, I'm going to come up with an answer in cubic feet. How the heck did they figure out from there what the how many gallons it would hold? I'm trying, wait a minute, I can't get out of here. I'm going to go back to the okay, so I had to look up to find out how many gallons in a cubic foot, and the gallons in a cubic foot is 7.48. So we said we had 542,592 cubic feet, 7.5. So I know how many cubic feet there are, and I know there are 7.5 gallons in every cubic foot. How do I figure out how many gallons this tank will hold?
You would have to find you would have to find like the volume and divide it by divided by however many cubic feet to figure out how many you need to fill the tank.
I'm gonna draw you a picture here. Shauna, do you have an idea how you would find it?
I'm sorry, find what?
How many gallons?
You done talking? Or no?
How many gallons and what? Or just
in
gallons, period?
in this huge
You done
tank
talking or no?
here?
Can we go back to it so I can see it?
Can we go back to what? Ah, that's what I want. I want
Excuse
to
me, yeah.
do. What happened to my? Oh, I'm struggling here today. There we go. All right. So I have this huge tank, right? And altogether, I know that it is 2,592 cubic feet. Of those cubic feet, I know that there are 7.5 gallons. So do you see, I've drawn my little, whoops, where is it? I've drawn my little cubic foot here. I know that every one of these cubic feet holds 7.5 gallons. How do I figure out how many gallons are in this tank?
You have to divide.
Do
You
you
have to
divide?
divide. You have to divide five. You have to divide the volume by the gallons. Is that right?
It is not right.
You have
If
to multiply it, right?
I'm sorry, what, Tayshana?
You have to multiply it because you're trying to figure out how many. So you have to multiply that number to get the total of the gallon. I think that's what I'm trying to go.
Okay.
You do have to multiply. So if one cubic foot has 7.5 gallons, I've got multiple cubic feet, then I'm going to multiply to find what the total is. So take your answer and multiply it by
You
7.
gotta go up.
What do you get?
Um. One second. I have to.
Can I see the answer again?
Which one?
Yes. Let me
Yo, put
see.
your head out the way.
5, 4, 2,
Mommy,
4,000. Yeah,
5,
4,000.
2,
That's 4 million. Whoa.
7.5.
Oh no, but they said
I
4
got
million gallons. It says 4
406
million gallons on the thing.
9440.
So
That's 4 million gallons.
yes, which is exactly what it said on
Yeah.
the side.
Yeah.
So that's how they feel. Like I had to stop and think. I did not know that particular fact that 7.5 gallons is in a cubic foot. So when I saw that capacity, at first I thought, oh, this is the answer. But then I said, wait a minute. When I find the volume, I don't find it in gallons. I find it in cubic feet. So how do I get from cubic feet to gallons? So I had to look that up and find out. But we have Google, so Google is out a lot. Hey,
That was cool.
yeah. So there's a real life example of the volume of a cylinder, and interestingly enough, there are 13 of these in that one location.
What are those?
Where?
What are those?
Well, they're they contain gasoline.
Okay.
Yeah. So if you put gas in your car, it is likely that it came through one of these huge tanks in the Cuyahoga Valley. That it gets brought in on tankers or on railway cars. They transfer it to these fuel, and then it goes out to the gas stations. We have a good supply of gasoline in the area that I took from that. It's 10 o'clock. We have some formulas that we can do next week. We are going to talk about interest and distance and total cost. So those are some more simple formulas that we actually use in real life.
Yeah.
All right. And Tylisha, I did do a lesson on slope. So if you want to take a look at that, and then if you still have questions, I am doing color tutoring on Tuesdays. Tuesdays at 8, video tutoring Thursday 6:30.
Okay, so Tuesday at 8, you said?
6 to 8.
6 to 8 tomorrow.
Uh-huh. And Thursday
Okay.
video tutoring, I'll do video tutoring from 6:30 to 7:30. But if you want to call, we can talk through, you look at the video on slope, and then we can talk through how to use it.
Okay. I watched your video on slope, and I liked it because it really helped me learn rise over run better.
Okay.
And it helped me learn how to plot the equation on the graph, but I still struggle somewhere in there, like when they tell me I had a question that said what is the equation for this graph, those kind of things I get stuck on.
Okay.
So it's just some parts of slope that I know, and then there's some parts that I don't.
Okay. We can totally work on that.
Okay.
All righty. Well, it was good to talk to all of you today, and I will see you next time.